Hi and welcome to another video. This is part 14 of the David Kerzel Hit Miss engine build, and in this video we're going to have a look at cutting the gears which will drive the cam on the engine, which obviously will drive the push rod and then open and shut the exhaust valve. As I've sort of said before in previous videos, the plans are all in Imperial and I've only got metric equipment, so the gears are going to have to be converted to metric. So I've had a look on the net and we've got a couple of pieces of software to use and obviously a website, a calculator as well. And what I've done is I've tried to change those over to the mod system and try and get as close as possible to the Imperial size. We'll have a look at the plans and then I'll explain it in a bit more detail. Here are the two gears what we're going to be making. You can't really see them because obviously they're hidden by the flywheel. But one is driven straight off the crankshaft and the other one is floating on a bearing system here. So if we go to the next page, you can just see the gears here. So there's a small one on the crankshaft and then a larger one which is being driven, which obviously has got a cam behind it and then pushes the push rod. You can just see that small gear there. So like I was saying, the gears are Imperial, and when it comes to machining, in the text it says about putting some small drill bits, a number 55 drill in the notches and then measuring across, or you know, like measuring across a set of wires. I haven't got none of that equipment and I haven't got no Imperial drills down to that size, so I'm going to use, like I said, the modular system. So we need to convert these gears over to metric. So I've done that online and we've come up with some settings here, and we're going to be using the module 0.8 system, 20-degree pressure angle. So I've punched in the side, I've punched in the amount of teeth we've got and the other necessary things, and this is what it's spat out. So we've got an outside diameter of 33.6 and the actual gear needs to be 33.3. So it's not going to be a huge amount of difference and it should be okay. And then we've got a tolerance here of +0 and -14, so that even brings us down closer to where we need to be. The pitch is the same, it's a 32 pitch, and then the whole depth of the tooth is 1.8 millimeters. So what I've done is I've drawn this in CAD, and this gives us a bit more idea of whether the teeth are going to actually mesh properly or whether they're going to bottom out. So this is our distance here between the two spindles, and the teeth actually, they're going to be pretty close. So what I done was I set the milling machine up and put the dimension head on, and then we've actually cut those teeth in aluminium, and as you can see here, they've come out really well, and there's a little bit of play in there, which for this setup is going to be fine. Tiny amount of play, and they don't bind. The teeth are actually pretty good. So yeah, so I'm happy with that. So what we'll do now is we'll go back onto the milling machine and we'll actually cut these out of brass, which is what it mentions on the plan. So for the smaller gear, I've just got a piece of scrap brass just out of the scrap pile, so that'll be ideal to make that one. And then for the larger gear, I'm going to use a piece of solid round. I didn't have no scrap thick enough actually for that one, so we'll just turn it out of this piece of solid. So the first job was to create a couple of arbors to turn these on. So what we'll do, we'll get them in the lathe and start to machine them, and then obviously once they're machined we can take this whole assembly over to the milling machine, and then we can cut the gears, the teeth in the blanks. So anyway, we'll get on there on the lathe and we'll start off and we'll do the small gear first. Well, the blanks are all set up and they're now ready to cut some teeth into. So obviously we've got the large gear and the smaller gear. And the rotary table I've set up to use as a dividing head. So this is our table for my particular type. I've got a Vertex rotary table. It's the model number is HV6 and that's got a 90:1 ratio. So down here the first column is all the divisions, and the first one we're going to cut is the 40 tooth gear. So here we look down the column until we find 40 divisions, which is here, and then we need to, there's 3 plates which comes with the rotary table, and each plate has got a series of holes on and a quantity of holes going round on the plate. So I'll show you that as we look at the rotary table in a minute. So for 40 teeth we need plate A, and we need to pick the outside ring for 20. And here it's telling us the turns what we need. So like I say, I'll show you in more detail on the rotary table in a sec. The other thing what we obviously need is an involute gear cutter, which is one of these. And if I just bring in a piece of paperwork and I'll show you here. So we've got module 0.8, pressure angle 20 degrees, and in that series, or in most of the series, there's a number 1 through to 8. And like on number 1 we can cut between 12 and 13 teeth, number 2 14 and 16 teeth, and so on. So we want 40 teeth, so we're down here at number 6, which is a range between 35 and 54 teeth. So like I say, there's 8 in a set of these, and I've got the number 6 cutter already set up on the mill itself on an arbor. So we'll now go across to the mill and then we'll have a look at the rotary table and the setting up of that. So the rotary table is all clamped down to the mill table itself, and everything is now square to the cutter and parallel to the table in both directions. So like I was saying, we've got the plate already on here, and we've picked the outside ring, which is the 20 hole ring. So as we turn this around, you'll see that the rotary table spins, and we've also got to set these fingers up, because in the drawing it said for 40 teeth or 40 divisions to use plate A, and we need a series of 2 turns. This is in between each tooth cut, 2 turns plus 5. So if we come back to the dividing wheel here, so what we do is we'll cut our tooth and then we want to move on to the next one. Excuse me. So we pull the pin out and then we need to go 2 rotations, 1, 2, and then we need to go on to 5 spaces. So if I go back to here, so when it says 5 spaces, it means 5 in between the holes, 1, 2, 3, 4 and 5. So once we do that, we can then cut our next wheel. Then we'll move on to the next one and go 1, 2 turns plus 5, cut our tooth, and then so on until we go all the way round the blank and we get to back, you know, obviously to where we start, and hopefully the last tooth we cut is exactly in the right place. So anyway, we'll get this blank set up in the chuck and then we'll start the cut. I've already got the involute cutter set up, so this is set up dead center to the center of the gear. If it was off center, then obviously we'll be cutting crooked teeth. So we can now bring this in and we'll start to cut our first tooth, and then we'll work our way round until we hit 40 teeth. I've just touched the cutting teeth on the blank. I've just touched off right on this very side here, and we now need to wind the table in 1.8mm, and that's going to be the depth of our tooth to the root. And we'll lock the table, then we can start cutting. So that's 40 teeth all cut, so I'll just bring you in and we'll have a look. And there you can see all teeth are perfect, so that was good, worked out well. So we can take this one out now because that's complete. Obviously there'll be a bit of some burrs on the back here, so what we'll do, we'll pop this back in the lathe and we'll just tidy those burrs up. Anyway, we'll load the other one up. So this time we've got to come back to our table and we want 20 teeth cut on the smaller gear. So here's our divisions here, which is 20, same plate, A, and then this time we want 4 turns plus 10 spacers. So we'll change the fingers. So we want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And tighten the lock and screw up. So now what we do each time, we'll go 4 turns, 1, 2, 3, 4, plus 10 spacers. So we'll just come back where we start from and we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just double checking, that's all. Right, so we'll set the cutter back up on the touch off on the back of this gear and then we'll start our cut. and just there. So we'll set the DRO again. And this has got the same depth of cut, which is 1.8, 1.8. We'll lock the table, and then we'll start cutting these teeth. Right, so we'll do a dry fit onto the crank on the engine, and we'll see how these gears have turned out, see how they mesh. What way? I can't remember what way round they go now. I think that's that way. We'll soon find out. Put the cam on as well, and that does up onto here. I think that has come out perfect. That gear's tight as it gets in closer to the centre there. Yeah, I might just have to give that a little tickle on that gear, because just in here where it comes up against that bush is really tight just there. So it's alright how it here, but there is a real tight fit on the shaft, which is obviously what you want. So we just push it into about there, and then we should be able to see. So yeah, but no, I'm really happy with that. And there's only a little bit of play in there. Obviously it needs a tiny little bit of play, obviously, because the teeth have got to come round, you know, and on the pressure and that. But no, that's come out really well. Really happy with that. But that gear is a pain in there being that tight. Oh, I'm happy with that. That's come out really well. Good. Another job done. So all I've got to do on the cam itself, I think that goes around that way from memory. I've just got to put a small wire in here which locks it to this gear. And I can't remember what size it was now. It said a piece of stainless steel wire or something like that. You know, quite a thick piece of wire or pin or something like that. Just drill a tiny hole and then put through the cam and through the gear. And then that'll lock those two together. So yeah, so those have come out really well. Really happy. Well, if you like this video, please like and subscribe, and we'll see you in the next video. Thanks for watching.